Hello my dear students, I am B S Pandey. Today we are in a particular lecture that will complete another experiment today my dear students. Okay, it is the second experiment. It will be the second experiment of your standard 12th course. Okay, we have done the one experiment and here we are moving for the second experiment in standard 12. Okay, so it will be the experiment number 2, my dear students. What will be the aim of experiment here, my dear students? You have studied in theory portion about the meter bridge, that is the slide wire bridge. Okay, and on the basis of that particular instrument, we have to do an experiment today. All right. Remember, in your syllabus, you have to actually maintain a total 12 experiment, 6 from each section, but this is here especially due to the sorting of your syllabus. You have to perform only 4 experiments from each section, and we are in lecture number 2 today. Okay, it is the experiment. Kindly write down the aim of experiment, my dear students. In first experiment, I have explained all the things that you have to maintain the steps while writing the experiment. Okay, so the aim of experiment. Aim of experiment. It is, you will write, to find resistance. To find resistance of a wire or standard resistor using meter bridge. Meter bridge or the slide wire bridge, and hence find the specific resistance. Specific resistance. You know, my dear students, it is also called the resistivity. Okay, that will represent by the rho. Now, my dear student, to find this particular resistance of a wire or a standard resistor, it means you will get the resistor. It is supplied by the supplier. Mention the standard value over that resistor, and the resistance wire, my dear students, from a coil we will cut out a resistor of particular length, that is made up of constituent, manganese, etc. Okay, any alloy, and we will try to find out resistance of that particular wire. Okay, here it is the aim of experiment. We know that the step to do this particular experiment, we require material. Okay, so the required material, my dear friends, these are the steps. Remember, you have to follow. I'm telling you, after this aim of experiment, you have to write the required apparatus. I will just include a video clip that will demonstrate you how to perform the experiment. Okay, in that video clip, it is mentioned all the required materials. By just pausing that video, you can write down the required materials. So we will write down the required materials. You have to leave the 6 to 7 lines in your record copy to write down the required material. After that, we used to write the theory or principle. Okay, so the next step, it will be the theory or the principle. Student, we know that actually this meter bridge, okay, this meter bridge works. This is the meter bridge that we are doing here. The meter bridge works on the principle of, the principle you will write, the principle works on balanced Wheatstone bridge. Wheatstone bridge you can write. Okay, so it works on the balanced Wheatstone bridge, my dear students. Now the second thing, remember students, one thing, if you are getting problem in my writing, then I'm telling also how you have to just listen and try to write down the work. It works on balanced Wheatstone bridge. And now the theory. Remember what you have to do actually. You have to find out the resistance of a wire and then a specific resistance. So to find the resistance, we have studied another circuit diagram will be also there. So for resistance, we know that the formula, it is unknown resistance, suppose it is X, is equals to 100 minus L divided by L into R. Here R is known resistance that we will take from resistance box. Sorry, resistance box. Remember students, in your record copy of experiment, you have to write all the things what I'm writing here. In the same way, you have to maintain your record copy, experiment record copy, that you will have to submit at the time of examination, okay, for the value of 30 marks. The record copy will be of 6 marks. All right, here. So in this way, after calculation of this L and R will be the known resistance, we will be able to find out the known resistance. My dear students, L will be the balanced length. Balanced length. And this balanced length, for this particular balanced length, actually we have to do the experiment. Okay. Now, one thing more, my dear students, while you will see the clip that I'll just include here after this particular introduction of this lecture or the experiment, my dear students, you will get in that video, it is written this one. It is L by 100 minus L times R, X equals to. You can see both the formula are different. So don't be confused, my dear students. Actually in that clip, it has not calculated the value, but only the formula it is written. And in that clip, actually the balance length has been taken from near the known resistance. That's why the formula has been written like this way. Okay, so don't worry, you have to leave that particular just part. You have to use this part for the calculation, and all the things I will give you here in my lecture. You have to see only in that clip how to perform the experiment, how the apparatus looks like, because you know that in lab I will give you, this is the virtual lab actually, but in real lab we will again study all the things in very detail. Okay, now this is for the resistance. Now for the resistivity. Or this is the specific resistance. That is the rho. We know that the formula R, it is equals to rho L by A. In this way, we can find out the rho is equals to R. And what is R? Actually, we are doing the experiment for the unknown resistance. That's why we write here the X. So it is X A divided by L. Now, how will find the value of A? So it will be the cross-sectional area of the wire, and this A can be written as pi r square. Using a screw gauge, we will calculate the radius that we have been used in last experiment also, in experiment number 1. Those students have not watched my experiment number 1, kindly go to the previous video and try to find out the lecture the experiment number 1. Okay, so we'll find the radius and we'll take the length using meter scale. We'll have all the values here, the area, length, and the X we will calculate from the first part, and then after we will able to calculate the here specific resistance, that is the resistivity. In this way we have to do the experiment. My dear students, this is the theory part. Only this much we have to write, not more than that. Okay. After theory, what we used to write, my dear students? Let me rub the board. After theory, we used to draw the diagram. If we are doing the experiment of electronics, that is electricity, then we write the circuit diagram. So we'll write circuit diagram. Our next step, it is the circuit diagram. From where you will get the circuit diagram? In that video clip, my dear students, the circuit diagram, it is mentioned very clearly. Okay, so there will be the two clips. In one clip, my dear students, you will get all the things, that is the material required and how to work. But I will just include another clip of 3 minutes, and that will I will explain personally how you have to perform the experiment. Okay, my dear students, in this way you have to do the experiment. So, my dear students, let's have a look on that particular clip, and you have to be careful. Try to note down the required material from that clip, and also you have to understand very well how you have to perform the experiment. Okay, and try to memorize it, how the apparatus looks like. Okay, because inside the lab I will give you all the apparatus you have to arrange by yourself. Okay, so let's have look that video clip.
Meter bridge, resistance of a wire. The property of a conductor to oppose the flow of charges through it is called its resistance. In this experiment, our aim is to find the resistance of a given wire using a meter bridge and hence determine the specific resistance of its materials. Materials required: a meter bridge, jockey, Leclanché cell, resistance box, galvanometer, key, connecting wires, wire cutter, scale, resistance wire, and sandpaper. Procedure: first, make the connections as shown in the circuit diagram. Take a connecting wire and cut it using a wire cutter. Connect one end of the wire to the positive terminal of the Leclanché cell and the other end to terminal A of the meter bridge. Now take another connecting wire and connect it between the negative terminal of the Leclanché cell and one end of the key. The other end of the key is connected to the terminal B of the meter bridge with another connecting wire. Introduce the resistance box in the gap G1 of the meter bridge. Now, take the resistance wire and connect it in the gap G2 of the meter bridge. Since the resistance of the wire depends on its length, make sure that both ends of the resistance wire just touch on the gap. With other connecting wires, connect the positive terminal of the galvanometer to the central terminal of the meter bridge and negative terminal of the galvanometer to the jockey. Now insert the key and press the jockey near A and then near B. If the galvanometer deflections are in opposite directions, then the connections are correct. Now, press the jockey almost at the middle of the wire on the meter and introduce a suitable resistance R in the resistance box so that the galvanometer shows zero deflection. Measure the distance L1 from the terminal A to the balancing point. Now, interchange the position of the resistance wire and resistance box in gaps G1 and G2. Measure the distance L2 from the terminal B to the balancing point. Then calculate the mean balancing length L. Then calculate unknown resistance using the equation X is equal to L whole divided by 100 minus L into R. Repeat the experiment for different values of R, and mean value of the resistance X gives the resistance of the wire. Measure the radius R of the wire using a screw gauge. If L be the length of the wire, then the specific resistance of the material of the wire.
Students, you have seen how you have to perform the experiment. Here, I am giving you the procedure. We'll connect the components according to the circuit diagram. You can see all the markings are given here in this circuit diagram. Look at here carefully. This is your meter bridge, left gap, right gap, and between A and C, the wire. Connect an unknown resistance or wire in the left gap of the bridge. Here this is your meter bridge. You can see here we have connected a resistance wire, that is the unknown. Connect the negative terminal of the galvanometer to the point D of meter bridge. Here you can see this is the point from where we are connecting the meter bridge. This is the connecting wire, and this will goes to the negative terminal of galvanometer. Now connect the positive terminal of the galvanometer with jockey, that is pen like that you have to slide. Here we are connecting. This is the conductor. Now we have connected along with the jockey. You can see this is the jockey. I will provide in physics lab. Connect the resistance box in the right gap. Remember students, this resistance box is the known resistance. Here you can see we have connected the resistance box, one terminal with the meter bridge and the second terminal with the other terminal of the meter bridge. Now it is connected. Connect point C to the meter bridge to the negative terminal of the plug key. We'll connect the one-way key. Now this is the source. You have to connect this negative terminal with the one-way key, and the second one we will connect the positive terminal of the plug key to that second negative terminal. Here you can see it is the second terminal which is connected with the battery eliminator. Now connect the positive terminal of the battery to the rest end of the meter bridge to complete the circuit. Now your circuit is completed with this connection. Now student, I know that you have watched that video clip. Here I am having the observation table. I have been observed while I have I used to facilitate the student inside the lab. I am having the observation. I am giving you all the observation and result as well, but that particular value we will try to obtain inside the lab when school reopen. Okay student, so look at here. I am having all the things. It has been noted down. Okay, I have not memorized the value actually. I have been noted down. I have been kept here. You can see it is below in written in my copy here. Okay, now so we'll write observation table after that circuit diagram. We are going to observe, but remember after circuit diagram you have to write the procedure. The next step will be procedure. And that procedure in second clip, my dear student, I will tell you step by step all the things that you have to mention in procedure. Okay, point wise, and it would be maximum 6 to 7 points, not more than that. Okay, so after procedure we have to do the calculation. For that calculation we require observation table. So it is the observation table. Here first serial number, second It is the, remember, we'll use the known resistance, and that will be represented by R. It is in ohm. Okay. Now it will be the balance length. It is represented by L. We will try to keep it in centimeter, and then we will write the values after or each small calculation, the value of X on the basis of these two value, and how much it will be 100 minus L divided by L into R, that is the known resistance, and we will calculate this value also in ohm. Okay, look at here one by one. How many observations we are going to take here? The 2, 3, 4 and 5. 5 observations we are taking. If we take 5 ohm as a known resistor from resistance box, we got the balance length. It is 42 centimeter, and on the basis of that 42 centimeter, I have calculated, I got the result 6.9 ohm. Now in second observation, I took 10 ohm out of the resistance box, then I got the balance point. It was showing at 61 centimeter. After calculation, I got it was at 6.4 ohm. Okay. Now the third observation, I picked 20 ohm from the resistance box, that is the known resistor, and I got the value 75 centimeter. On the basis of that 75 centimeter, I have calculated and I got 6.7 ohm. You can see the slight variation in this one, and the source of error will be the number of things, that is we are using the apparatus continuously. Alright, that's why due to the variation of temperature might be the resistance is changing. Alright, then after I took resistor of 25 ohm, and then I got the balance length as 81 centimeter. On the basis of this calculation values, I got the value of unknown resistance. It was 5.7 ohm. Alright, now the last observation, I took 30 ohm out of that particular resistance box. I got the value, it was 85 centimeter, and then the value I have calculated, it was as 5.3. Now this is your experiment. Actually this is the basic part of your experiment, that you have done the experiment. Okay my dear students, now you have to do the calculation on the basis of this observation table. Okay, although you have done some calculation here also to find out the values 6.94, 6.7, 5.7, 5.3. okay, and don't just get confused why this large deviation in the results. Actually this is the result that you got from your experiment. You are not writing by somewhere else. Okay, here I got the value that I am giving you my dear students. You can also find out the values, might be it will be little different. Okay, on the basis of this one, we will do the calculation. Our next step, it is calculation. After that, we will find the result. Okay, for the calculation, my dear students, what we got the average resistance, that is the known resistance. First we have to find the calculation of unknown resistance. The first, okay, the value of X. So we have calculated here the different value of X, but we know that 5 observations are there, so we'll get any one observation and it will be the average. So the average resistance, it can be written as the sum of all the values 6.9 plus 6.4 plus 6.7 plus 5.7 plus 5.3 divided by 5. I think I should use the black pen for the clear visibility. Here, after this calculation, I got the value, my dear student, it is 31 divided by 5, and it was 6.2 ohm. Alright, so we got the average resistance as, that is the value of X as 6.2 ohm. This is our experimental finding. Now the one calculation we have done. The second calculation, what we have to do, we have to find the specific resistance. So let me move for the specific resistance. Now for a specific resistance, what you require length of the conductor, length of the wire, and the length of the wire we have already taken, it is 40 centimeter. Alright, we are finding here the results in centimeter, CGS unit. After calculation, resistance we got, it is 0.21 centimeter. The resistance, it was calculated as 0.21 centimeter. It was calculated using screw gauge. Alright, yes. Now here let me do some calculation to find the resistivity. Okay, yes. So resistivity, it is, we know that the formula 100, sorry, this was for the resistance, no? It is X into pi r square divided by length. X, it is the known value, unknown value of resistance that we got here. Okay, so it is 6.2 into pi 3.14 r square divided by length. It is 40 centimeter. You are getting all the values, remember my dear students, in CGS system. So after calculation we got, this is as 0.021 ohm centimeter. This is the resistivity. Now my dear students, the last you can write the results. Okay, it is the result. So what you got from the experiment? The first, unknown resistance. That is X. What you got? 6.2 ohm. The second, specific resistance. That is the resistivity. How much you got? It is rho as 0.21 ohm centimeter. My dear students, you must do calculation by yourself. Okay, to verify whether this calculation are up to mark or not. You can do the calculation, but you have to use that particular table I have given you. Okay, my dear friends. So this is the complete observation and experiment number 2, how we find the specific resistance and resistance using meter bridge. My dear students, we will do 2 more experiment on the basis of this one, but in examination you will get it is mentioned as the optional or. Okay, you have to do either this one or you have to verify the law of combination, series and parallel, using the same meter bridge. You have also studied in standard 10th the verification of combination of series, combination of resistor as series and parallel using Ohm's law. The same thing we have to do here, but using the meter bridge. Okay, my dear students. So this is all about today's experiment number 2. We will perform the next experiment in next week, my dear students. Thank you very much.